What truly occupies the void between the stars? It is certainly not simple emptiness. Instead, you can picture a vast galactic ocean overflowing with gas, dust, energy, and magnetic fields. I invite you to join me on an exploration of this invisible expanse, a realm where cosmic enigmas unravel and the very foundations for new generations of stars are forged. Every single drifting particle and every filament, cloud, or stream in space carries the potential for a story that is yet to be told, offering us a chance to perceive the universe's hidden pulse.
When you look up at the night sky, it is incredibly easy to become captivated by the sheer beauty of the stars. But have you ever stopped to think about what is concealed behind those shimmering points of light? I want you to imagine a reality where those specks are actually colossal spheres of incandescent gas, separated by distances that are nearly impossible for the human mind to grasp. Every star you can see is a member of a galaxy, and our own Milky Way is just one of countless billions that populate the cosmos, a fact that serves as a powerful reminder of our own scale in this boundless expanse.
The majestic Milky Way is far more than a simple cluster of stars. Its grand spiral design, with arms extending outward like cosmic tendrils, provides a clear illustration of how stars and the surrounding space are fundamentally organized. This interstellar medium is anything but a lifeless vacuum. It is a profoundly dynamic environment, where matter and energy are in a state of constant, complex interaction. Have you ever considered how interstellar space is connected to everything we observe? Every planet, every star, and every piece of matter within our galaxy is in perpetual motion, navigating this immense cosmic sea. Although we often describe space as empty, it is actually a surprisingly complex medium, a mixture of particles, radiation, and magnetic fields that define its character. In many ways, it is like the air you breathe, unseen, yet filled with essential elements that shape our world. To truly appreciate the scale of interstellar space, you have to reconsider how we measure its enormous distances. Here on Earth, we use kilometers, but in the cosmos, the standard is light years. A single light year represents the distance light covers in 1 year, which is roughly 9 trillion kilometers. This means that when you gaze at the night sky, you are quite literally looking into the past, as the light from those stars may have journeyed for many years, or even centuries, just to reach your eyes.
The stars nearest our own solar system are already light years away, with many forming the familiar patterns we know as constellations. These arrangements are not merely beautiful sights. They are woven into ancient tales of mythology, and have served as crucial guides for explorers throughout human history. But looking beyond these celestial signposts, what really lies behind the light? The answer can only be found by venturing into the heart of interstellar space. In any discussion about the contents of the cosmos, it is impossible to ignore dark matter and dark energy, despite their invisibility. We are certain of their existence because of their profound influence on the structure and motion of the universe. These unseen forces function like the essential threads in a cosmic tapestry, binding galaxies together and dictating their large-scale movements, which presents a deep mystery that continues to challenge our fundamental understanding of reality. One of the most incredible processes unfolding in interstellar space is the formation of stars. This phenomenon originates within nebulae, which are immense clouds of gas and dust drifting through the void. Under the right gravitational conditions, these clouds begin to collapse, sparking the birth of new stars. This endless cycle of creation and destruction turns the vastness of space into a stellar forge. And it is truly remarkable to realize that every single star you see has its own unique origin story. And what should we make of black holes? These bewildering objects are formed from the gravitational collapse of the most massive stars, resulting in regions of space-time so distorted that nothing, including light itself, can escape their pull. Their very existence forces us to ask profound questions about the fundamental nature of space and time. What truly occurs inside a black hole remains one of the greatest puzzles confronting the limits of our scientific knowledge. As our exploration of the cosmos continues, it naturally leads us to contemplate interstellar travel. Could humanity one day traverse the immense gulfs that separate the stars? The concepts for achieving such a feat are as varied as they are fascinating, ranging from antimatter-powered vessels to the theoretical possibility of wormholes. Human ingenuity is limitless, and if I told you we might one day discover a way to travel faster than light, it would fundamentally alter our entire civilization. Another captivating frontier in our cosmic journey is the ongoing search for extraterrestrial life. Scientists are now capable of looking beyond our solar system, identifying exoplanets that orbit other stars within their habitable zones. The sheer possibility that life could exist on these distant worlds fills us with a profound sense of wonder and optimism. As our scientific capabilities advance, an answer to this age-old question may finally be within our reach. Gravity, the familiar force that anchors you to the Earth, also commands a central role across the interstellar medium. This pervasive force governs everything from the orbital paths of planets to the very formation of galaxies. It is a fundamental architect of the universe, shaping its grand structure and ensuring that the cosmos is not a chaotic, weightless void. Can you even imagine a universe without it? Exploring the cosmos is much like being a mariner on an infinite ocean, where the tools and techniques for navigation are both critical and ingenious. Our ever-advancing technology, from powerful telescopes to robotic space probes, has enabled us to continually extend the frontiers of what is known. This relentless expansion of the universe itself is another source of awe, compelling us to ask how it is possible that everything, everywhere, is in a state of constant outward motion. The Big Bang Theory provides a framework for understanding how everything began, while the universe's continuous expansion shows it to be a dynamic, ever-changing environment. This outward push influences not just the galaxies, but also our perception of the space between stars. Cosmic events like supernovae and pulsars serve as constant reminders that space is full of surprises, with each explosion and pulse signifying a moment that has helped shape the cosmos. These occurrences are more than just spectacles. They offer deep insights into the universe's underlying principles. Our ability to comprehend and explore space is undeniably shaped by technology. From the earliest telescopes to the probes that have journeyed past our solar system, every technological leap has moved us closer to solving the universe's riddles. The future of space exploration is brimming with both incredible opportunities and formidable challenges, leaving us to wonder what discoveries await in the vast galactic sea that envelops us. As we venture deeper into this ocean of stars, remember that each question we pose about the cosmos opens the door to new answers and new knowledge. The Milky Way itself is like an immense ocean of stars, a cosmic home to our solar system that spans billions of light years. But what is our real place within this galactic structure? To begin, visualize the Milky Way as a flat, spinning disk of stars, gas, and dust, dominated by a luminous central bulge that holds the majority of its mass. This core region is populated by some of the galaxy's most ancient and brilliant stars, while the spiral arms extending from it are where you will find most other stars, including our own sun. When you gaze into the night sky, it's easy to get lost in the splendor of the stars. But it's crucial to remember they aren't isolated points of light. The interstellar space between them is just as significant as the stars themselves. Have you ever considered what might occupy this seemingly empty expanse? Contrary to its appearance, interstellar space is a complex environment filled with gas, dust, and magnetic fields, all of which are essential to the Milky Way's structure and function. The distances separating the stars are almost too vast to comprehend. For instance, our nearest stellar neighbor, Proxima Centauri, is 4.2 light-years away. To grasp this scale, consider that even traveling at the speed of light, the absolute fastest anything can move, the journey would take over 4 years. This enormous gulf between stars, which we define as interstellar space, is a fundamental component of our galaxy's dynamics. Think about the star patterns that trace familiar shapes across the night sky, forming constellations that have guided us and told stories for ages. It's important to realize that these stars are not all at the same distance. Some are relatively close, while others are thousands of light-years away. We determine this using a method called parallax, which involves measuring the apparent shift in a star's position as observed from different points in Earth's orbit, allowing us to better map our location within the Milky Way. The Milky Way is not solely composed of things we can see. It also harbors mysterious elements like dark matter and dark energy. Despite being invisible, these two components exert a tremendous influence on our galaxy. Dark matter forms an invisible scaffold that holds galaxies together gravitationally, while dark energy is the force responsible for accelerating the expansion of the entire universe. Though we cannot directly observe them, their effects are evident in the motion and distribution of stars. The life cycles of stars present another captivating dimension of our galaxy. Stars are born inside dense clouds of gas and dust known as nebulae, where gravity causes material to collapse and ignite, creating new suns. This process is not just a beautiful cosmic event. It serves as a powerful reminder that interstellar space is far from static. Instead, it is a galactic workshop engaged in an eternal cycle of creation and destruction. Nebulae, these massive clouds of gas and dust, truly are the stellar nurseries of the cosmos, lighting up in a brilliant display of colors as new stars form within them. But what becomes of stars when they exhaust their fuel? Some collapse to become black holes, one of the universe's greatest enigmas. These objects are so dense and their gravitational pull so powerful that nothing, including light itself, can escape, raising profound questions about the fundamental nature of space and time. Amidst these cosmic realities, the prospect of traveling between the stars remains a very distant ambition. How could we ever hope to traverse the immense voids of interstellar space? Theories propose advanced technologies, from spacecraft capable of navigating through wormholes to vessels propelled by enormous solar sails. While these ideas may seem like science fiction now, humanity's innate curiosity has always pushed us to explore beyond the known horizon. In the meantime, the search for life beyond Earth has evolved into an incredibly exciting endeavor. Scientists are actively scanning the cosmos for exoplanets located in habitable zones, regions where conditions could potentially support life. Each new candidate discovered brings us a small step closer to answering one of humanity's most ancient questions. Are we truly alone? This quest to explore interstellar space is not just a journey outward, but a profound search to understand our own existence and our place within it. As we plan for future exploration, cosmic radiation presents a significant obstacle. This radiation, originating from sources like our sun and distant stars, poses serious risks to space travel and astronaut health. Mastering how to shield against and manage this radiation is absolutely essential for any mission that aims to venture into the depths of interstellar space. Ultimately, it is gravity, the same force that keeps our feet on the ground, that orchestrates the grand cosmic dance of the Milky Way, holding stars in their orbits and governing the motion of entire galaxies. Without this underlying structure, the cosmos would be an environment of pure chaos, and what we observe in interstellar space would appear entirely different. The task of navigating this expanse is a monumental one, which is why astronomers and scientists have devised a range of methods and tools to find our bearings in this vast, stellar ocean. From incredibly powerful telescopes to probes journeying to the frontiers of our solar system, every technological leap brings us a little closer to grasping the full complexity of the Milky Way. The continuous expansion of the universe also raises new questions about the destiny of our galaxy and our own position within it. This cosmic growth forces us to reconsider how we relate to the space around us and what it implies for the long-term stability of galaxies and star systems. Within this framework, cosmic events like supernovae and pulsars are far more than just brilliant celestial shows. They are profound lessons on the life and death of stars, with each stellar explosion teaching us about the universe's cycles and reminding us of its ever-changing nature.
The impact of technology on our comprehension of space is impossible to overstate. Every innovation, from the first telescopes to the most advanced exploratory probes, has broadened our cosmic horizons. As we continue to push these boundaries, ongoing research and the creation of new technologies are set to completely transform our exploration of the space between stars. It is thrilling to contemplate what the future of space exploration holds, as each new finding moves us closer to solving the great mysteries of our galaxy and the interstellar medium.
When you picture the expanse between stars, your mind likely conjures an image of a vast, lifeless vacuum, an endless stretch of pure darkness. But what if I were to tell you that this supposed void is not nearly as empty as it appears? The reality is that interstellar space is far from a desolate place. It is instead filled with remarkable elements that we are only just beginning to comprehend. Let's begin by re-examining the very idea of emptiness, a concept redefined by the cosmos.
Here on Earth, our concept of space is shaped by an abundance of air, water, and life. In interstellar space, however, the particle density is astonishingly low, yet this does not mean it contains nothing at all. Are you aware that a single cubic meter of this space can hold anywhere from 1 to 10 hydrogen atoms? While this is infinitesimal compared to Earth's atmosphere, it serves as a crucial reminder that even the most seemingly empty regions of space are still populated by matter.
What might surprise you is that this near vacuum, despite its low density, is saturated with energy. Electromagnetic radiation, which includes everything from visible light to X-rays and radio waves, is constantly journeying through this void. To make this more concrete, imagine space as a vast ocean. Although it may seem empty, it is filled with energy waves moving through it, much like swells across the water. Every photon of starlight that reaches your eye has traveled across this immense cosmic sea. Furthermore, this emptiness isn't just a passive void. It's a dynamic environment containing magnetic fields and subatomic particles engaged in complex interactions. Picture an intricate web where each strand is a magnetic field line, guiding and capturing particles as they drift through space. Though invisible to us, these interactions have a profound effect on the behavior of stars and other celestial objects, shaping the very structure of the galaxy. The question of temperature in space also challenges simple assumptions. While many believe it to be uniformly cold, the reality is a realm of stark extremes. In the vicinity of stars, temperatures can soar to hundreds of thousands of degrees.
In contrast, within the deep voids far from any stellar radiation, the temperature can plummet to near absolute zero. This dramatic difference highlights just how dynamic and varied this environment truly is.
Researchers have also found that space is filled with minute particles of dust and gas, which are considered the fundamental ingredients for life. These particles sometimes coalesce into vast clouds, which are known as nebulae. If you can imagine a cosmic dust cloud drifting through the void, you are picturing the birthplace of stars. These nebulae demonstrate that even within this apparent emptiness, a perpetual cycle of creation and destruction is always at play. And while space is often described as silent, that's only because sound as we perceive it cannot travel in a vacuum. However, the cosmos is far from quiet. It resonates with shock waves and other vibrations that propagate through different mediums. This reveals a universe of sounds that we cannot hear, but that are integral to cosmic processes. If we could somehow listen, space would offer a symphony of cosmic phenomena. Among the most enigmatic features of this void are black holes. These are formed from the collapse of massive stars, creating regions of gravity so powerful that nothing, not even light, can escape. Here, the void transforms into a point of immense attraction, where matter seems to disappear rather than simply exist. This discovery poses fascinating questions about the fundamental nature of space and the behavior of gravity in its most extreme forms. The nature of time itself is also transformed within the cosmic void. Unlike the consistent flow we experience on Earth, time and space can be altered by gravity and velocity. This means that two different observers, one standing on a planet's surface and another hurtling through space, could experience the passage of time in completely different ways. It is as if the void has its own distinct and extraordinary rhythm. These invisible forces present tangible challenges for exploration. As we venture further from our solar system, spacecraft must navigate through magnetic fields that can subtly influence their trajectory and speed. Navigating these cosmic currents requires immense precision and a profound understanding of physics, turning interstellar travel into a delicate cosmic dance. Human curiosity remains a powerful engine, and perhaps one day we will finally cross the great ocean of stars that surrounds us, ready to explore not only our own galaxy, but the infinite universe that lies beyond. Have you ever found yourself looking up at the night sky, captivated by the sheer spectacle of the stars? Yet, have you considered what truly occupies the space between those brilliant points of light? The immense ocean stretching between stars is known as interstellar space, and the distances that define it are almost beyond our ability to grasp. Today, we're going to explore how this abyss is measured, and what its vastness truly signifies for us. To begin, let's tackle the concept of cosmic distance. If you picture the universe as an enormous city, then each star is like an individual building. However, unlike the familiar streets that connect our neighborhoods, there are no visible pathways linking these celestial bodies. The key to understanding their separation lies in a familiar unit of measurement: the light year, which is the distance that light, the fastest traveler we know, covers in a single year. Imagine a beam of light moving at a velocity of roughly 300,000 kilometers per second. This incredible speed means that in just 1 year, light can traverse nearly 10 trillion kilometers. To give you some context, if light were to race around our planet, it could circle the Earth more than 7 times in a single second. With this in mind, you can begin to appreciate the scale we're dealing with when we talk about light years separating the stars. Consider Proxima Centauri, the star nearest to our own solar system, which is 4 light years away. This implies that even with a hypothetical spacecraft capable of traveling at the speed of light, the journey would still take 4 years to complete. The reality is, we have no such technology. Our fastest probes, like the Parker Solar Probe, reach speeds around 200,000 kilometers per hour, turning a trip to Proxima Centauri into an epic voyage lasting thousands of years. Now, let's zoom out to the colossal distances within our home galaxy, the Milky Way, which spans a diameter of approximately 100,000 light-years. The Milky Way is home to somewhere between 100 and 400 billion stars, a number so vast it's difficult to truly comprehend. These immense scales can also evoke a profound sense of isolation, as the vast stretches of space between each star, while filled with gas and dust, often appear like cosmic deserts.
This so-called emptiness is what we refer to as interstellar space. Although we might think of a void as containing nothing, in the cosmos, this space is teeming with particles, radiation, and a variety of phenomena we are still working to understand. To measure these distances, astronomers employ several techniques, with one of the most clever being parallax. By observing a star from 2 different points in Earth's orbit, we can measure its apparent shift against the background and thereby calculate how far away it is.
And what happens when we look beyond our own galaxy? The expanse of space becomes even more staggering. The Andromeda Galaxy, our closest major galactic neighbor, is situated about 2.5 million light-years from us. Just think, if you were to send a message to a civilization in Andromeda, you would have to wait 2.5 million years for their reply. This is the true scale of intergalactic space. These vast distances also fundamentally change how we perceive the cosmos. The light from the most remote stars has traveled for thousands or even millions of years to reach your eyes. Consequently, when you gaze at the night sky, you are not just seeing stars as they are now. You are witnessing the ancient history of the universe. The sky itself becomes a storyteller, narrating tales across immense spans of time. When we look at the night sky, we naturally see patterns. And humanity has been grouping these stars into constellations for millennia. These celestial maps are more than just navigational aids. They are woven with the ancient myths and heroic legends of past civilizations. As we observe these stellar arrangements, we can identify which stars are our closest cosmic neighbors and which are far more distant, giving structure to the void. The challenge of understanding this cosmic void raises profound philosophical questions that go beyond mere science. If this emptiness actually contains something, how does that alter our perception of the universe? Could it be possible that other life forms or entire civilizations exist in the most isolated corners of space? It is the relentless search for these answers that propels our continued exploration of the cosmos. Ultimately, the concept of emptiness in interstellar space is far more intricate and compelling than one might first assume. This vast cosmic ocean is filled with particles, energy, and countless mysteries, inviting us to push the boundaries of our understanding. So, the next time you gaze up at the star-filled sky, remember that the darkness between those stars is a vibrant and dynamic realm, a world full of secrets just waiting to be discovered. Consider Proxima Centauri, the star nearest to our solar system, which is situated more than 4 light-years from us. This incredible expanse means that a journey to reach it, traveling at the speed of light, would require over 4 years, a feat that remains firmly in the realm of science fiction for the time being. Can you even begin to grasp the scale of such a voyage across the cosmos? A constellation is much more than a mere chance arrangement of stars. We recognize these groupings by their distinct shapes, such as the famous ladle form within Ursa Major. In reality, These stars are not neighbors at all, but lie at vastly different distances from Earth. To determine their true positions in our three-dimensional universe, astronomers employ a method called parallax, which calculates distance by observing a star's apparent shift from different points in our planet's orbit. At times, what you perceive as a single point of light in the night sky is actually a complex stellar system. The Alpha Centauri system, for instance, consists of 3 separate stars locked in orbit around one another. You can picture a magnificent cosmic dance as these celestial bodies move in concert through space, bound by their intricate gravitational relationships, which makes you wonder how many similar performances are happening across the galaxy. Constellations have also served a vital practical purpose throughout history. For ancient mariners navigating the vast, featureless oceans, these star patterns were essential tools for guidance, allowing them to reach their destinations safely. Even today, with all our advanced technology, gazing up at the same stars our ancestors used creates a profound and timeless connection to the human story. Stars are far more than simple specks of light. They are immense elemental factories. Deep within their cores, nuclear reactions forge heavier elements like carbon and oxygen. When a massive star reaches the end of its life, it can detonate in a supernova, an explosion that scatters these newly created elements throughout space. This means that with every breath you take, you are inhaling atoms that were once part of a distant, long-dead star. A reminder that we all carry a piece of the universe inside us. Observing the familiar patterns in the night sky naturally leads you to question what might exist beyond our own atmosphere. The constellations act as an invitation to imagine these distant points of light as hosts to other worlds, perhaps even harboring life. In recent decades, this curiosity has fueled an intensified scientific search for exoplanets, which are worlds that orbit stars other than our Sun. Stars provide the stage for some of the most spectacular events in the cosmos. A supernova explosion, for example, is not only a star's dramatic finale, but also a creative act, forming vast clouds of gas and dust known as nebulae. These nebulae then become the stellar nurseries where new generations of stars and planets are born, demonstrating a fundamental principle of the universe. Nothing is ever truly lost, only transformed. When you look up at a constellation, you might also find yourself contemplating the possibility that humanity is not alone in the universe. This question drives scientists to scan distant star systems for planets that lie within the habitable zone, the specific orbital distance where conditions could be suitable for life to emerge. What if one of those worlds is another cradle of life? Beyond their aesthetic appeal, constellations are fundamental tools that enable our exploration of the cosmos, teaching us about the universe's history and inspiring us to find answers to our deepest questions. Each star represents a chapter in a vast cosmic story that is continuously unfolding. As our technology advances, our capacity to understand space grows, and with it, so does our relentless curiosity. The sheer beauty of the stars serves as a powerful reminder of our small place within the immense universe. Yet it also sparks an unyielding drive to keep exploring. Astronomy doesn't just reveal the contents of the sky. It connects us directly to the core of our own existence. So, the next time you look up, remember that every star is an invitation to dream and to discover more about the vast and mysterious home we all share. Have you ever wondered what most of the universe is actually made of? The reality may be quite surprising. Despite being filled with stars, planets, and galaxies, the vast majority of the cosmos is entirely invisible to us. This is because about 95% of the universe consists of dark matter and dark energy, two mysterious components that dominate the fabric of space.
Dark matter is a substance that is completely undetectable by conventional means because it doesn't emit, absorb, or reflect any light. Imagine being in a pitch-black room. You might not see anything, yet you can sense the presence of objects around you. Similarly, we know dark matter exists because its gravitational pull influences the motion of stars and galaxies, even though its true nature remains one of science's greatest unsolved puzzles. Dark energy, however, operates in a completely different way. It is the mysterious force responsible for the accelerating expansion of the universe. To visualize this, think of blowing up a balloon. As you add more air, the balloon's surface expands at an increasingly rapid rate. Dark energy exerts a similar influence on space-time, pushing galaxies further and further apart. So, how can we be certain that dark matter and dark energy exist if they are invisible? Scientists have inferred their presence by meticulously observing starlight and the large-scale structure of galaxies. By studying how stars move and how galaxies cluster together, it becomes evident that there is far more mass and energy present than what we can see. Much like how you can infer powerful underwater currents by observing the subtle motions on a lake's surface. This brings us back to interstellar space, where dark matter plays a critical and foundational role. It is believed to be the cosmic scaffolding upon which galaxies first formed, and its gravitational influence is essential for holding them together and ensuring their stability over billions of years. Without the influence of dark matter, stars would lack the necessary gravitational cohesion to remain intact, leading to the dissolution of our galaxies. It effectively serves as the fundamental adhesive that holds the universe together across the vastness of interstellar space. Dark energy, on the other hand, acts as a constant reminder of the universe's dynamic nature. As the cosmos expands, the distance between galaxies grows into an immense void, fostering an environment entirely inhospitable to life as we understand it. Yet this expansion also provides a unique chance for us to explore and comprehend the cosmos on a deeper level. Each time you look toward the heavens, you are observing not only the history of the stars, but also a future in a state of continuous evolution. This brings forth a compelling question. Could dark matter and dark energy contain the answer to the universe's ultimate destiny? Some scientists propose that the interplay between these two forces will dictate whether the cosmos expands forever, or eventually halts and begins to contract. Such a scenario, termed the Big Crunch, would revert the universe to its original primordial state, possibly initiating an entirely new cycle of creation. It is truly astonishing to reflect on how, despite our own relative insignificance in the cosmic expanse, it is the puzzles surrounding dark matter and dark energy that propel our quest to explore beyond the visible. These profound mysteries challenge us to fundamentally rethink our conception of the universe and our own place within its structure. The ultimate question remains: will we ever manage to uncover the true nature of these mysterious cosmic components? As explorers of the cosmos, we are engaged in a perpetual journey of discovery. Every time we deploy a new telescope into orbit, or innovate new technologies to measure the universe, we act on the hope of finally decoding the secrets that dark matter and dark energy have held for so long. The more we learn about these phenomena, the more it becomes apparent that the universe is filled with endless surprises and mysteries that await our discovery. The importance of dark matter and dark energy cannot be emphasized enough. They are not only pivotal elements in our pursuit of understanding, but are also integral to the very fabric of the cosmos. Viewed this way, interstellar space is not merely an empty expanse, but a dynamic arena where dark matter and dark energy perform the principal roles. So, the next time you gaze upon the starry sky,
remember that there is profoundly more than what your eyes can perceive. The stars are just the visible surface of a vast and enigmatic reality, inviting us to continue our exploration.
One of the most fascinating questions we can contemplate while looking at the night sky is how stars are formed. These brilliant points of light that punctuate the universal darkness did not simply materialize from nothing. Their existence is the outcome of a process, an intricate cosmic dance that plays out within enormous clouds of gas and dust. This entire process is initiated within nebulae, colossal clouds of hydrogen, helium, and other elements that drift through interstellar space. Inside these nebulae, the force of gravity begins to draw particles together, causing them to accumulate and form clumps. Over time, a dense core takes shape, and it is at this point that the truly magical part of star birth begins. Gravity functions like a cosmic magnet, and as an increasing amount of material gathers in this core, both pressure and temperature begin to climb dramatically. At this stage, the core becomes so intensely hot that it ignites nuclear reactions, triggering thermonuclear fusion, a process that unleashes a staggering quantity of energy. This released energy generates an outward pressure that precisely balances the immense gravitational force attempting to collapse the core, allowing the star to achieve stability and shine. If gravity were to dominate, the star would implode. If the fusion pressure prevailed, the star would fly apart. Thus, a newborn star is defined by this delicate equilibrium. However, stars are not all uniform. Their size and brightness are dictated by the quantity of material they accumulated during formation. More massive stars consume their fuel much faster, while smaller stars can shine for billions of years, each with its own internal clock. Once formed, a star settles into a phase known as the main sequence, where it will spend the majority of its life. During this extensive period, the star fuses hydrogen in its core to produce helium, releasing vast amounts of energy in a stable process that can last for millions or even billions of years, depending on the star's mass. But when a star finally depletes its hydrogen fuel, a dramatic transformation begins to take place. If the star is sufficiently large, it will start to fuse helium into heavier elements like carbon and oxygen, developing new layers much like an onion. This process can cause the star to expand dramatically into a red giant, potentially swallowing any planets in its orbit. Smaller stars, including our Sun, follow a different trajectory and will eventually become white dwarfs. After their fuel is spent, they cast off their outer layers, revealing a hot, dense core that will glow for billions of years before gradually cooling into darkness. And what becomes of the most massive stars? Their collapse can set off titanic explosions known as supernovae, which are among the most spectacular events in the cosmos. For a brief moment, a single supernova can outshine an entire galaxy. These incredible explosions are responsible for forging heavy elements such as gold and iron, which are then dispersed throughout space, providing the raw materials from which new stars and planets will eventually form, perfectly illustrating the universe's cycle of renewal. Every star's existence, from its birth to its death, helps give rise to successive generations of stars in a process that resembles a grand cosmic symphony. Within this eternal melody, each star contributes its own unique note, turning interstellar space not into an empty void, but into a magnificent stage for incredible sagas of creation and destruction to play out. This is the arena where matter is constantly transformed and reshaped, forging the very fabric of the cosmos as we understand it. When you look up at the night sky, it's worth remembering that every point of light is the culmination of an amazing journey, starting from its formation in a nebula and ending with its dramatic demise in a supernova. Each star embodies a narrative of transformation and renewal. So the next time you find yourself gazing upward, consider the intricate process that created it. You'll see that every star stands as a monument to the elegance and complexity of our universe, with star formation being just one of countless marvels in the surrounding galactic ocean. Have you ever found yourself staring into the night, curious about what exists beyond those twinkling stars? Within the vast expanse of interstellar space lies some truly extraordinary phenomena known as nebulae. These are immense clouds of gas and dust that drift through the cosmic darkness, functioning as colossal stellar nurseries for the universe. Think of them as places brimming with potential, where the conditions are perfect for new life, in this case, new stars, to emerge from the raw materials of the cosmos. The formation of these cosmic clouds is a direct result of the death of old stars. When a truly massive star depletes its fuel, it culminates its existence in a spectacular explosion called a supernova, which blasts all the elements it forged, like hydrogen, helium, and heavier materials, out into space. You can picture it as a magnificent cosmic fireworks show, where the lingering remnants become the essential building blocks for entirely new generations of stars to form. Within a nebula, the environment is ideal for new stars to take shape, as clumps of gas and dust start to coalesce under the relentless pull of gravity. This process marks the very first stages of stellar evolution, a fascinating and intricate sequence of events. As fragments of this material collapse inward, the core temperature and pressure skyrocket, eventually triggering the immense energy release of nuclear fusion and marking the birth of a brand new star. Beyond their function as stellar nurseries, nebulae are genuine masterpieces of cosmic art, with some appearing so vivid and colorful they could be mistaken for paintings. The Orion Nebula, for instance, is a breathtaking spectacle with its signature pink and blue tones. The reason for this vibrancy is found in their chemical makeup. The light from newborn stars excites the surrounding gas, causing it to glow at distinct wavelengths and produce the stunning palette of colors that you can observe. It's important to realize that nebulae are not all identical. They come in various types, each telling a unique story. You have emission nebulae, which shine brightly because their gases are energized by the light of young stars within them. Then there are reflection nebulae, which don't produce their own light but instead scatter the light from neighboring stars. Finally, you have dark nebulae, which are so dense with dust and gas that they completely obscure the light from stars located behind them, creating imposing silhouettes against the cosmic backdrop. Here is a truly intriguing thought. Nebulae harbor the fundamental ingredients for life itself. Scientists have detected complex molecules inside them, including water and amino acids, which are the very building blocks of life as we understand it. This discovery inevitably leads to a captivating question. Could life be emerging elsewhere in the cosmos, born within the confines of some distant nebula? Nebulae serve as a testament to the continuous life cycle of stars, where the death of one star can give rise to a new nebula, perpetuating an endless cycle of cosmic creation and destruction. By studying these massive clouds, astronomers gain profound insights into the universe's past, piecing together its evolutionary history. Analyzing nebulae is akin to opening an ancient manuscript and deciphering secrets that have been hidden for eons. Our investigation of nebulae extends far beyond Earth-based observations, as modern telescopes and advanced spacecraft allow scientists to examine these structures in remarkable detail. Every new image we acquire offers more data on their formation, their evolution, and their specific role within the grand cosmic narrative. You could even think of nebulae as cosmic laboratories, where unique experiments in creation are constantly underway, each with its own distinct blend of elements and environmental conditions. When you contemplate these distant nebulae, it offers a moment to reflect on our own position within the cosmos. We are an integral part of this immense universe, where new stars are continuously being forged from the recycled dust and gas of their predecessors. So as you look up at the starry sky, remember that every single point of light you see might be the outcome of a process that started in a nebula, a powerful reminder that you are connected to something far grander than yourself. Let's now turn to one of the most captivating mysteries of the universe: black holes. What are they? And what explains their profound hold on our imagination? Picture a point in space with a gravitational pull so intense that absolutely nothing, not even light itself, can break free. This is the fundamental nature of a black hole, an object that comes into being when a massive star runs out of fuel and collapses in on itself, creating a zone of extreme gravity that defies our conventional understanding of the cosmos. The question of what truly occurs within a black hole leads us to the heart of the enigma, a concept known as a singularity. This is a theoretical point where all the black hole's matter is compressed into a state of infinite density, causing the fabric of space-time to curve so intensely that our current laws of physics break down. In this environment, the physical laws that govern our reality simply break down. You find yourself entering what feels like a completely separate dimension, where our fundamental concepts of space and time no longer apply. We often refer to the event horizon as the boundary that encircles a black hole. Once you pass this point of no return, escape is impossible. Think of it as teetering on the edge of a precipice. Lean too far, and you will inevitably fall without any hope of getting back. This comparison helps illustrate the function of a black hole as a cosmic snare from which nothing can ever break free. So, you might ask why black holes are so significant within the broader context of interstellar space. Their very existence offers profound insights not just into the life cycles of stars, but also into the fundamental structure and dynamics of the entire universe. At the heart of most galaxies, including our own, lie supermassive black holes that are instrumental in shaping galactic formation and behavior. They function as the gravitational anchors around which entire star systems and other celestial objects revolve. A truly captivating aspect of black holes is their interaction with the matter surrounding them. They inexorably draw material inward, creating a structure we call an accretion disk. This swirling disk is composed of gas and dust spinning at incredible velocities, a process that unleashes tremendous amounts of energy. As intense friction heats this matter to extreme temperatures, it radiates energy that our telescopes are capable of detecting. This means that while the black hole itself remains invisible, we can clearly observe its powerful effects on the space around it. And what can be said about primordial black holes? Some theories propose that these objects could have formed during the universe's initial moments, born from the extraordinarily dense conditions of the Big Bang. These ancient black holes would likely be much smaller than their modern counterparts and could be lurking unseen in the vast emptiness of intergalactic space. Confirming their existence would undoubtedly revolutionize our understanding of cosmic history. The concept of black holes has also served as a powerful muse for science fiction, fueling our curiosity and pushing our imagination to its limits. Countless films and novels have delved into related ideas like wormholes, which are theoretical tunnels connecting distant points in space-time. While these notions remain largely in the realm of speculation, they encourage us to envision the extraordinary possibilities of navigating the cosmos. Black holes also offer us a profound lesson about the nature of time itself. As you venture closer to a black hole, time begins to behave in very peculiar ways.
To a distant observer, an object falling toward the event horizon would appear to slow down, its motion stretching out infinitely. This phenomenon, which we call time dilation, stands as one of the most astonishing predictions of Einstein's theory of general relativity.
Studying these cosmic enigmas forces us to confront some of the deepest questions imaginable. Could black holes serve as gateways to other universes? Is it possible that we will one day develop technology capable of exploring these cosmic depths firsthand? Science is perpetually moving forward, and every new discovery about black holes brings us a step closer to answers that could fundamentally alter our perception of reality.
Another critical aspect is the role black holes play in the birth of new stars. The matter that gathers in the accretion disk doesn't always fall in. Some of it can be violently ejected back into space, occasionally triggering the formation of new stars. This perpetual cycle of cosmic destruction and rebirth is a vital part of the galactic ballet, where the demise of one celestial body can spark the creation of many others.
Ultimately, while black holes might seem like objects of pure terror, they are equally a source of immense wonder. They serve as a constant reminder of how little we truly comprehend and how much of the universe still awaits discovery. Each new piece of data we gather is like finding another piece of a grand cosmic puzzle that we are still far from completing. They inspire us to continue our exploration, to keep posing questions, and most importantly, to never stop dreaming. In the end, black holes are far more than mere astronomical curiosities. They represent gateways to the universe's most guarded secrets, fundamentally challenging our understanding of time, space, and existence itself. Every black hole is a testament to the fact that there is so much more to learn within the boundless galactic ocean that surrounds us. As our journey into the cosmos continues, these mysterious objects will surely remain a central focus of our fascination and a powerful symbol of the mysteries we have yet to solve. Interstellar travel is a dream that has captivated human imagination for generations. The real question is, how close are we to making this profound ambition a tangible reality? The notion of crossing the immense void between stars can easily feel like a fantasy reserved for science fiction. However, the truth is that a significant body of research and theoretical work is already dedicated to figuring out how we might one day reach other star systems. The first question you might pose is, what is the driving force behind our need to travel between the stars? The answer is both straightforward and deeply inspiring. Venturing into deep space not only expands our understanding of our own planet, Earth, but also presents the chance to find new worlds, potentially new life, and perhaps even essential new resources. It's like peering through a portal into humanity's future, a future where expansion beyond our solar system becomes not just a dream, but a necessity. One of the most formidable barriers to interstellar travel is sheer distance. The stars are separated by unfathomable expanses, and our current technology is simply not equipped to traverse these distances within a human lifetime. Take, for instance, Proxima Centauri, the nearest star to us. It lies more than 4 light-years away. To give you some perspective, even a vessel traveling at the speed of light would need over 4 years for a one-way trip. With the spacecraft we have today, such a journey would extend for many thousands of years. So, how could we possibly overcome such a staggering obstacle? One idea that has gained serious traction among scientists is the solar sail. Picture a vast, reflective sail, perhaps the size of a major city, being pushed through space by the pressure of sunlight or by powerful, Earth-based lasers. This concept could theoretically enable a spacecraft to achieve remarkable speeds by harnessing the gentle but constant force of light itself. It may sound like something from a fantasy, but it's a concept grounded in the real physics that governs our universe. Another fascinating possibility is the use of antimatter for propulsion.
While it might sound like a technology pulled directly from a futuristic film, you should know that antimatter is a very real substance. It is the opposite of ordinary matter, and when the two come into contact, they annihilate each other, releasing an immense amount of pure energy. Harnessing this power could provide a source of propulsion far more efficient than anything we have ever created, potentially making journeys to other stars a feasible endeavor. An immense burst of energy occurs when matter collides with its counterpart, antimatter. Despite this potential, producing and containing antimatter remains extraordinarily difficult and costly. Even so, research into this area continues, and it may one day offer a practical solution for the travel of future generations.
Another compelling idea involves black holes. Have you ever considered the possibility of a shortcut through the very fabric of space-time? A black hole could theoretically link two remote locations in the cosmos, enabling instantaneous travel between them, much like a secret passage to a faraway destination. While the theory is captivating, we have yet to discover such a passage, or figure out if one could be artificially created and sustained. Consider, too, the prospect of exceeding the speed of light. While this defies the known principles of physics, some theories propose it could be achieved with concepts like Alcubierre warps, which would manipulate space itself by expanding it behind a vessel and contracting it in front. This would permit crossing enormous distances in remarkably brief time frames without violating cosmic laws, but the idea remains purely speculative and requires a great deal of further investigation.
The ambition of interstellar exploration extends beyond simply arriving at new star systems. It encompasses the vision of settling other worlds. What if we were to discover another planet like our own, a place to begin a new branch of civilization? Becoming a species that inhabits multiple planets is not only a thrilling prospect, but could also be crucial for ensuring the long-term survival of humanity. Before we can undertake such ambitious voyages, however, a host of problems must be solved. Life on a spacecraft during an extended journey presents significant hurdles for keeping the crew healthy, engaged, and productive. The logistics of providing food, along with managing waste recycling and oxygen generation, pose a tremendous challenge that demands truly creative solutions. Furthermore, the psychological well-being of the astronauts is of paramount importance, as the profound loneliness and isolation of deep space can inflict serious mental harm. It is therefore essential to create effective strategies to support the emotional health of the crew. Entertainment, virtual reality, games, and consistent communication with home could prove vital for maintaining morale during the long journey. Furthermore, the psychological well-being of the astronauts is of paramount importance, as the profound loneliness and isolation of deep space can inflict serious mental harm. It is therefore essential to create effective strategies to support the emotional health of the crew. Entertainment, virtual reality, games, and consistent communication with home could prove vital for maintaining morale during the long journey. As we forge ahead with new spacefaring technologies, it is wise to apply the lessons learned from our history of exploration on Earth. Principles such as international cooperation, mutual cultural respect, and responsible resource management are absolutely essential. The grand endeavor of exploring interstellar space could ultimately unite humanity, bringing us together to achieve a shared objective. So, when you gaze up at the night sky, allow yourself to contemplate the boundless possibilities. What incredible discoveries are waiting for us in the immense expanse of space? The quest for interstellar travel is merely the start of a saga that could fundamentally alter our perception of the universe and our place within it. The great adventure is just getting underway. with a future filled with wonder and mystery.
Have you ever paused to consider the sheer scale of the universe and the profound questions it inspires? Among the most captivating of these is whether we are truly alone in the cosmos. For generations, the search for life beyond Earth has fired the imaginations of scientists, artists, and visionaries alike. But what practical steps are we taking in this quest? And what techniques do we employ to detect any hint that we share this vast universe with others? To grasp the search, it's helpful to understand that life as we know it depends on a precise set of circumstances. Scientists refer to a concept called the habitable zone, which is the specific orbital region around a star where conditions are just right for liquid water to exist on a planet's surface. You can think of it as the perfect residential area, where a planet is neither too close to its star to become scorching hot, nor too distant to freeze over. Looking beyond our own solar system, we see billions of stars in the Milky Way, many of which are orbited by their own families of planets. This presents a vast ocean of possibilities where astronomers hunt for exoplanets, worlds that circle stars other than our sun. Missions like the Kepler Space Telescope have already confirmed the existence of thousands of these distant worlds, though the search continues for one that could actually support life. One of the primary techniques for spotting these exoplanets is known as the transit method. The process is quite elegant. When a planet's orbit causes it to pass directly between its star and our line of sight, it momentarily obstructs a tiny fraction of the star's light. By detecting this subtle dip in brightness, scientists can confirm the planet's presence, allowing us to perceive far-off worlds through nothing more than a faint flicker in the distance. Our search for life, however, isn't confined to just finding other planets. We also actively listen for potential radio transmissions from intelligent civilizations. Projects such as SETI, which stands for the Search for Extraterrestrial Intelligence, utilize enormous radio telescopes to monitor the skies for any unusual signals that might be artificial in origin. It's an endeavor akin to trying to overhear a single conversation in a massive, noisy stadium, where every faint sound must be carefully analyzed. The core challenge lies in knowing what kind of signal to listen for, as well as the immense distances involved. While it's theorized that advanced societies might broadcast messages into the cosmos, any signal we receive would have traveled for thousands, if not millions of years. This means that if we were to detect something, it would likely be an echo from a civilization that existed in the very distant past. This grand search also includes locations much closer to home. Scientists are increasingly focusing their attention on the moons of Jupiter and Saturn, particularly Europa and Enceladus. These celestial bodies are covered in thick ice sheets that are believed to conceal vast, hidden oceans of liquid water beneath. These subsurface oceans could provide environments perfectly capable of harboring life, making them some of the most exciting targets in our quest. Whenever you look up at the night sky, do you ever find yourself wondering if other worlds capable of supporting life exist out there? This very curiosity has propelled both scientists and dreamers to investigate the immense reaches of space, seeking out exoplanets, which are planets that orbit stars far beyond our own solar system. Their very existence raises profound questions and fuels our deepest fascination with the cosmos. To grasp the scale of it all, you can picture a solar system as an elaborate celestial ballet, with each planet moving in a carefully choreographed orbit around its star. While our own system contains 8 planets, astronomers estimate there could be billions of worlds orbiting other stars throughout the Milky Way alone. The potential diversity is staggering, ranging from gas giants like Jupiter to smaller, rocky planets similar to Earth, each holding unknown possibilities. In recent decades, our ability to find these distant worlds has been completely transformed by advanced telescopes.
One of the most effective techniques is known as the transit method. It works like this. When an exoplanet crosses directly in front of its star from our point of view, it causes a very slight, temporary dip in the star's brightness. This minuscule dimming, almost imperceptible, is the critical clue that unlocks the discovery of an entirely new world.
Of course, the existence of exoplanets is captivating not just for their variety, but for their specific locations in space. Some orbit within what is called the habitable zone, a precise region where the conditions could be just right for liquid water to exist on a planet's surface. The hunt for these worlds is like searching for a specific grain of sand on an infinite beach, but the thrill of finding one is simply beyond description.
For scientists, discovering an exoplanet is only the first step. The next is to understand its nature. This phase involves carefully studying its atmosphere, its physical makeup, and its potential climate. Can you imagine the breakthroughs that would allow us to determine if a distant world has clouds, oceans, or perhaps even the telltale signs of biological activity? The very idea that we could find tangible evidence of life millions of light years from home is truly astonishing.
However, the search for life on these worlds is filled with immense challenges, the most significant of which is distance. Exoplanets are so incredibly far away that reaching one with our current technology remains firmly in the realm of science fiction. While brilliant scientists have proposed some fascinating concepts for interstellar probes, these ideas are still largely theoretical and far from becoming reality.
Fortunately, the technology we use to observe exoplanets is in a state of constant evolution. Next-generation instruments, like the James Webb Space Telescope, are engineered to see the universe in ways we never could before. This powerful telescope is capable of analyzing the faint light that filters through an exoplanet's atmosphere, allowing us to search for chemical compounds that could point to the presence of life.
This leads us to the concept of biosignatures, which are essentially chemical hints of life on another planet or moon. Here on Earth, living organisms produce gases like oxygen and methane, which fill our atmosphere. If we were to detect these same gases in the atmosphere of an exoplanet, it would be a powerful indication that life might be present there, stirring a new chapter in our search.
The thought that life could be thriving beneath the icy shell of a distant moon or in some other alien environment is both thrilling and deeply humbling. It raises a fundamental question. If we do find life, what will it actually be like? It could be entirely unlike anything we know, perhaps simple single-celled organisms in a dark ocean, or even advanced civilizations that have mastered technologies we can't yet imagine. The truth is that life could appear in forms we have never conceived of, which only adds to the mystery of our cosmic search.
In this quest, the role of space missions is absolutely vital. Every new undertaking, from sending robotic probes to Mars to using telescopes to study the atmospheres of distant exoplanets, brings us another step closer to answering that profound question. Are we alone? This exploration provides us with invaluable data, but it also inspires us to gaze at the stars and truly consider our own place within the universe.
The search for extraterrestrial life is so much more than a scientific project. It is a journey that connects with the very core of our human identity. It forces us to ask deep questions about our own existence, to venture into the unknown, and to dream on the grandest scale. As we push further into the cosmos, we are, in many ways, also exploring the depths of our own humanity. So, as you stand beneath the starry sky, remember that every single one of those stars is a sun, and each of those suns holds the potential to nurture worlds where life could flourish. This search is not just about reaching a final goal. It is a shared human journey that reminds us that in the boundless expanse of the universe, we are a small but brilliant flicker of light,
searching for companionship in the vast, silent dark.
It's worth remembering that regardless of what divides us, we are all united by a natural fascination with the cosmos. When you consider the chances of life-sustaining worlds beyond our own, it prompts a deeper reflection on our planet and the importance of its preservation. Our Earth is a precious sanctuary in the immense emptiness of space, making its protection our collective duty. And this quest for extraterrestrial life underscores the delicate nature of our own existence and the value of everything we hold dear. Ultimately, our venture into the study of exoplanets is only just getting started. Every new finding moves us nearer to solving the most profound questions of our species, urging you to gaze at the night sky with ambitious dreams. It serves as a reminder that within the immense cosmic ocean, innumerable tales are still waiting to be discovered. The search for alien life is as much an inward journey into our own identity and cosmic significance as it is an outward exploration of space, leaving us to wonder what marvels the future might hold. But what if I were to tell you that whenever you gaze up at the night sky, you're looking at more than just stars and constellations, but also through a pervasive sea of cosmic radiation? It's true. The void between stars is saturated with this radiation, and grasping its fundamental properties is essential for humanity's journey into the cosmos. While it might seem like an invisible and benign force, this phenomenon profoundly affects our methods of travel and exploration once we leave the safety of our world. You can think of cosmic radiation as a continuous current of particles flowing through the vacuum of space. These particles, the majority of which are born far outside our solar system, behave like microscopic projectiles traveling at velocities approaching the speed of light. Their origin can be traced to cataclysmic celestial events, such as the explosions of massive stars known as supernovae. Consequently, each particle that arrives at our planet is effectively a dispatch, carrying news of violent cosmic occurrences that took place millennia or even eons ago. This naturally leads to the question of what these particles actually are. The primary components of cosmic radiation are protons, electrons, and the nuclei of helium atoms, which you could visualize as minute packets of energy journeying through the immense expanse of the universe. While this radiation is omnipresent, our world is shielded by its magnetic field and atmosphere. The situation becomes far more complex, however, once we move beyond this natural barrier. Astronauts on missions, like those aboard the International Space Station, are subjected to radiation intensities far exceeding anything on Earth, and the health risks from long-term exposure are a critical consideration for future voyages to Mars and other destinations. So, how exactly do we quantify this cosmic radiation? To measure it, we rely on instruments known as particle detectors, which function like sensitive cosmic sensors. These devices are designed to capture and tally each particle that passes through them, providing a clear picture of the radiation's intensity at any given point in space. You could compare it to being at a live show with a clicker to count every instance your favorite song is performed. The detectors operate similarly, logging each individual pulse of radiation they encounter. However, this phenomenon isn't solely a hazard. Cosmic radiation also serves as an invaluable source of data about the wider universe. By analyzing the interactions and decay patterns of these particles, scientists can deduce the makeup of the celestial bodies from which they were launched. This process is akin to a detective gathering evidence to unravel a grand cosmic enigma, where every single particle represents another clue in the puzzle of the universe. Beyond its scientific significance, cosmic radiation has also found its way into popular culture, where it's frequently depicted in films and literature as a constant, unavoidable threat to space travelers. In reality, while the risk is certainly genuine,
Progress in protective technologies is helping to lessen the danger. Engineers are currently designing new spacecraft and suits using advanced materials capable of offering much more robust shielding from this ever-present radiation.
Picture a time when humanity journeys to distant star systems. In that future, what part will cosmic radiation play? It represents a formidable obstacle that we are compelled to surmount. As our exploration of space continues, our preparations must account for the persistent barrage of radiation, in addition to weightlessness and the sheer duration of the trips. This necessity forces us to ask critical questions about the construction of our vessels and the protective strategies we must implement for the next generation of space pioneers.
Our curiosity naturally pushes us to ask whether cosmic radiation could have an influence on life itself. Although our atmosphere shields the majority of life on this planet, scientists are studying organisms known as extremophiles that can endure extraordinary levels of radiation. This research suggests the fascinating possibility that if life does exist on other worlds, it may have developed incredible adaptations to survive in similarly harsh environments.
Cosmic radiation will remain an unwavering companion as we press onward with our exploration of the cosmos. Every new mission into space will present another chance to deepen our understanding of this phenomenon and its interactions with our technology and ourselves. So, the next time your eyes turn toward the stars, I want you to remember that you're witnessing not just points of light, but also a boundless sea of particles that have journeyed across space and time to bring you tales of the universe beyond.
Our captivation with cosmic radiation does more than just enhance our comprehension of the universe. It also equips us for what lies ahead. The exploration of space is an odyssey filled with immense challenges, and each new piece of knowledge we gain about radiation moves us closer to solving the cosmos's greatest puzzles. In the end, this phenomenon is a crucial element in our picture of interstellar space, and it serves as a powerful reminder that in the grand scale of the universe, no detail is insignificant. So, continue to look to the heavens and never stop exploring, as the cosmos always has a new lesson to teach.
Now, let's turn our attention to gravity, one of the most enigmatic and compelling forces in the universe. What exactly is gravity, and in what ways does it shape everything we see?
To grasp the significance of gravity across the vastness of interstellar space, you can think of it as an unseen network that links all of existence together. Imagine you are at a gathering where every person is connected by a string to a large ball in the center. The farther you step back, the tighter that string pulls, which is a simple analogy for how gravity operates throughout the cosmos, holding planets, stars, and entire galaxies in its grip while still permitting their motion through the void.
When you gaze up at the night sky, you are witnessing thousands of stars, engaged in a celestial ballet, choreographed by gravity. You might wonder why certain stars seem to be clustered together. The explanation lies in the pervasive influence of gravity. Although the stars within a single constellation can be at wildly different distances from Earth, gravity dictates their movements and their tendency to group together, acting over immense distances to unite everything in a universal dance. But what happens once we travel beyond the confines of our solar system and into the depths of interstellar space? Even in this immense emptiness, gravity remains a pivotal force, though its influence is perceived differently. Out here, a star's gravitational pull is significantly weaker than it is in its immediate vicinity. This is why astronomers, when tracking the paths of the most remote stars, must carefully factor in the gravitational effects of all other celestial bodies that could alter their trajectories.
So, what makes gravity fundamentally important? Consider the birth of new stars within the dense clouds of gas and dust inside a nebula, where gravity initiates its creative work. As particles are drawn together by gravitational attraction, the mounting pressure and temperature eventually trigger the formation of a new star. The process is much like kneading dough. The more you compact it, the denser it becomes, and gravity is the fundamental force that gets this entire process started. If we zoom out even further, you find that gravity also governs the interactions between entire galaxies. When two galaxies draw near one another, their mutual gravitational pull can result in a magnificent cosmic spectacle, a dance where stars and matter are exchanged between them. This event, known as a galactic merger, serves as a powerful reminder that our universe is an active and ever-evolving place, with each collision not only reshaping the galaxies, but also igniting the birth of new stars and planetary systems. There inevitably comes a point in a star's existence when its own gravity turns against it. After a star depletes its nuclear fuel, its core is no longer able to resist its own gravitational force and begins to collapse inward. This catastrophic collapse can trigger a supernova, an explosion of such immense power that it can briefly outshine millions of other stars. The very gravity that once bound the star together becomes the agent of its destruction, blasting its material into space and enriching the cosmos with the heavy elements needed for the next generation of stars and planets. In the realm of interstellar space, gravity also profoundly impacts our search for life beyond Earth. The exoplanets we discover orbiting distant stars are all governed by the gravity of their stellar parents. A key question for scientists is whether an exoplanet possesses the right conditions to support life, and the answer often depends on the gravitational relationship between the planet and its star. A planet needs gravity strong enough to hold on to an atmosphere, making it a potential candidate in our quest for life. However, gravity is not merely a force of attraction. It can also act as a powerful distorting agent. When light from a distant star travels past a truly massive object, like a galaxy or a black hole, gravity has the power to bend its path. This effect, which we call gravitational lensing, enables astronomers to view objects that would otherwise be too far away or too dim to detect. In this way, gravity functions as a natural cosmic telescope, helping us uncover the universe's hidden secrets. As we journey farther into space, gravity also poses significant practical challenges. Spacecraft trajectories must be plotted with incredible precision, accounting for the gravitational pull of every planet and celestial object along the way. Even a minuscule deviation of a few degrees could send a probe to a completely wrong destination. This makes navigating through space a high-stakes endeavor, where gravity is a constant variable that engineers must master for any interplanetary mission. Our future in space exploration hinges on a deeper understanding of gravity. Could we one day learn to manipulate gravity to achieve faster-than-light travel between the stars? Some scientific theories propose using the gravitational pull of planets as a slingshot to accelerate our spacecraft, effectively creating a network of cosmic highways. It's possible that gravity itself holds the ultimate key to unlocking the secrets of interstellar travel. The expansion of the universe is another grand process intrinsically linked to gravity. While the cosmos is expanding and galaxies are moving farther apart, gravity relentlessly tries to pull them back together. This cosmic tug-of-war pits gravity against dark energy, a mysterious force that pushes everything apart. Understanding this dynamic tension between these two opposing forces remains one of the most compelling challenges in modern cosmology. Ultimately, contemplating gravity reveals its role as a fundamental force that not only molds the structure of our universe, but also connects everything within it, from the genesis of stars to the collision of galaxies. Gravity is the essential thread that weaves the entire cosmic tapestry together. As our exploration of space continues, every new finding brings us a step closer to solving the profound mysteries of gravity and its role in the vast galactic ocean that surrounds us, inviting us to keep looking and to keep discovering the unknown.
Have you ever felt lost inside a sprawling labyrinth? Let's consider for a moment that interstellar space is a vast, dark, and enigmatic maze, where every star serves as a distant beacon. The fundamental question then becomes, how do we navigate our way through this cosmic labyrinth? Perhaps understanding the very rules that govern it, like gravity, is the first step to finding our path. The secret to traversing the cosmos is found in the art of space navigation, a discipline that I find is a blend of hard science, advanced technology, and a measure of intuitive skill. You have to understand, navigating through space is nothing like following a map on Earth, as there are no familiar roads or signs. Instead, you are confronted with unimaginable distances and the profound emptiness of the void.
So, you might be asking what instruments are available to help find the way in this boundless emptiness. Astronomy is one of the most foundational tools. By charting the positions of stars, explorers can pinpoint their location in the cosmos. Much like ancient mariners used the stars to cross vast oceans, today's spacefarers look to the heavens to plot their course, often relying on constellations as their cosmic landmarks.
Now, have you ever considered why certain stars seem stationary while others drift across the sky? The stars that compose a constellation are actually at vastly different distances from you, which can create a misleading perception of their movement. Despite this, recognizing these celestial patterns is key to navigating the great expanse, especially since the ground-based GPS systems you use daily are completely useless out in space. To overcome this limitation, engineers devised navigation systems that use radio signals traveling at the speed of light, enabling a spacecraft to determine its position with incredible accuracy. Just think about having the ability to pinpoint your coordinates on a three-dimensional map that stretches across light years. But when navigators need to go beyond simple constellations, they turn to a specialized technique called astrometry. Astrometry involves measuring the apparent motion of stars against the cosmic backdrop, which allows for precise adjustments to a spacecraft's flight path to keep it on target. However, space is not always predictable. Energetic explosions from the sun, known as solar storms, can disrupt navigation signals. It is in these critical moments that human ingenuity is truly put to the test. During such events, astronauts must depend on their extensive training and sharp instincts, correcting their course with the limited data available. In addition, gravity itself becomes a key navigational tool. As a spacecraft nears a planet, the world's gravitational pull can alter its path, a principle engineers exploit for gravity assist maneuvers to gain speed and change direction without burning precious fuel. Constant communication with mission control on Earth is also crucial, but you have to account for significant time lags. Given the immense distances, radio signals can take many minutes to travel, meaning a spacecraft must be equipped to handle emergencies on its own. It is similar to being on a video call, where your partner's response is delayed, forcing you to make decisions before you can get their input. Imagine you are on a vessel, drifting through deep space, enveloped in darkness, with only the stars for reference. In this situation, navigators employ what is known as inertial navigation. This system uses internal sensors to track the ship's acceleration and rotation, constantly calculating its position and orientation without any external references. Much like using instruments to know your location on a ship tossed in a storm.
For lengthy voyages, explorers rely on three-dimensional star maps that chart not just the locations of stars, but their movements over time, acting as cosmic roadmaps for planning routes far in advance. As you journey farther out, the challenges intensify. For instance, black holes represent points of such immense gravity that nothing can escape, making it absolutely essential to know their coordinates to steer clear of their influence. Spacefarers must also contend with dynamic hazards like comets and asteroids, where early detection via telescopes and radar is vital for collision avoidance. This brings me to the future of space navigation, which is poised for revolutionary advancements. New tools, from artificial intelligence-driven guidance systems to novel methods for measuring cosmic distances, are currently under development and promise to reshape how you explore the universe. Ultimately, navigating the cosmos is more than a mere technical exercise. It represents a profound journey of discovery. Each planet explored and every star reached deepens our understanding of the universe and our own position within it. With every voyage, the interstellar labyrinth seems a bit more familiar, as we gradually unlock the secrets of the vast galactic ocean that surrounds us. The expansion of the universe is a concept that, while abstract, fundamentally changes how you perceive the cosmos. You might be surprised to learn that the universe is not static. It is in a state of constant motion, a truly remarkable fact first discovered by the astronomer Edwin Hubble in the 1920s. To help you visualize this, I often picture the universe as a balloon. As it inflates, every point on its surface moves away from every other point, just as galaxies are drifting apart from one another as space itself expands. It was discovered that galaxies are speeding away from us, with their velocity increasing the farther they are. Isn't that an incredible thought? It's almost as if the cosmos is urging you to look further, promising that more lies beyond your current view. This very idea transformed our perception of the universe and compelled us to ask profound questions about its ultimate beginning and end. The expansion of the cosmos inevitably leads us to consider the Big Bang. This singular event, which took place roughly 13.8 billion years ago, is the origin point of everything that we can observe. Try to visualize an immense explosion that didn't just form stars and planets, but also brought time and space into existence. What preceded that first moment remains one of the greatest puzzles scientists are still trying to solve. A truly captivating consequence of this cosmic expansion is its effect on the light that travels to us from remote galaxies. As space itself stretches, the light waves journeying toward us are elongated, causing their color to shift. This phenomenon, known as redshift, is comparable to how a person's voice seems to dwindle as they walk away from you. In the same way, light from receding galaxies shifts toward the red end of the spectrum, offering vital clues about their speed and distance. But what does the future have in store for our universe? According to some theories, the expansion could persist indefinitely, resulting in what is called an open universe. Yet other compelling possibilities exist. You could imagine a cosmos that, after an eternity of expanding, starts to collapse back on itself like a slowly deflating balloon. This hypothetical outcome, termed the Big Crunch, suggests everything might one day return to a single, infinitesimal point. Exploring the universe's expansion also forces us to confront the nature of its composition. Scientific observations have revealed that the vast majority of the universe's mass is completely invisible to us. We are referring to dark matter and dark energy, two mysterious components that cannot be seen directly yet appear to be the primary drivers of this expansion, almost like an unseen engine pushing everything apart. So, where does gravity fit into all of this? Although gravity is the fundamental force that binds the universe together,
The cosmic expansion happens on such an immense scale that it can overwhelm gravity's pull, preventing galaxies from remaining clustered. This is a remarkable concept, reminding you that while gravity is immensely powerful, there are even more potent and enigmatic forces at play. As we investigate the universe more deeply, we are also prompted to reflect on our own significance within it. The relentless expansion can make you feel insignificant, yet it simultaneously connects you to a reality far grander than yourself. This journey through the cosmos is accompanied by the search for answers about who we are in this vast, unfolding story.
The narrative of cosmic expansion is a tale of continuous discovery and awe. Every fresh insight challenges us to reconsider what we believe we know and to embrace new, unfamiliar possibilities. This is more than just a study of distances and velocities. It's a profound search for truth in an enormous and perpetually transforming universe.
Science is in a constant state of flux, with new research emerging daily that could reshape our entire understanding of cosmic expansion. With every technological leap, from more powerful telescopes to increasingly ambitious space missions, we move a little closer to solving the great riddles of the cosmos. Just think of the new wonders that future generations will have the chance to uncover. Throughout this journey of inquiry, our most valuable asset is our sense of wonder. It is the driving force that compels us to continue exploring and to never stop asking questions. Ultimately, the universe is a place filled with mysteries and surprises, all waiting for you to find them. The expansion is a constant reminder that our pursuit of knowledge is a journey without an end. So the next time you look up at the immense star-filled sky, remember that every single star and galaxy is in motion. They are all part of a dynamic, cosmic fabric that is forever changing. The universe's expansion is an open invitation for you to dream bigger and explore further, because there is always so much more than what first meets the eye. Are you prepared to continue this voyage and see what the cosmos has waiting for us? Within the grand arena of interstellar space, certain phenomena exist that seem to be pulled directly from science fiction. Yet they are as real as the stars you see at night. Among the most breathtaking of these cosmic spectacles is a supernova. But what is it exactly? Picture a colossal star, many times more massive than our own sun, that eventually exhausts its nuclear fuel. At that point, it undergoes a titanic explosion, detonating like a cosmic bomb and unleashing a flash of light so brilliant it can be seen from thousands of light years away. Supernovae are far more than just spectacular explosions. They are fundamental to creating the very elements that constitute our universe. During this cataclysmic event, immense quantities of energy and matter are ejected into space, forging the elements essential for life itself, such as oxygen, carbon, and iron. In a very real sense, we owe our existence to these stellar detonations. Without them, the building blocks of our bodies, our atmosphere, and our world would not exist. As the light and matter from a supernova expand into the void, they leave a trail of heavy elements that enrich the interstellar medium, providing the raw materials for new stars and planets. This means that every time you witness a supernova, you are watching a cosmic cycle of death and rebirth unfold. It's truly incredible to realize that we are all made of stardust that once blazed brightly in the distant cosmos. However, supernovae are not the only marvels the universe holds. You can also find pulsars, which function much like cosmic lighthouses. When a massive star explodes, its remnant can collapse into an extraordinarily dense object called a neutron star. This star then spins at an astonishing rate, beaming out radiation in regular rhythmic pulses, almost as if it were broadcasting signals across the vastness of space. Consider for a moment receiving a transmission from a lone lighthouse adrift in the ocean. You could pinpoint its origin and even glean something of its nature. Pulsars function in a similar way, but on a cosmic scale. These captivating celestial objects serve as invaluable tools for studying the universe, with their metronome-like pulses acting as precise cosmic chronometers. This allows scientists to calculate immense distances, put gravitational theories to the test, and even hunt for the elusive ripples in space-time known as gravitational waves. Every pulsar is a beacon, illuminating our path through the enigmas of the cosmos.
Technology has truly become our most essential partner in the mission to comprehend the immense universe we inhabit. From humanity's earliest skyward glances to today's intricate interplanetary missions, every single breakthrough has broadened our cosmic horizons. Have you ever paused to think about how limited our knowledge of space would be without the aid of modern telescopes? These remarkable instruments do more than just extend our vision beyond its natural limits. They have fundamentally reshaped our entire interpretation of the universe, preventing countless wonders from remaining forever veiled in celestial darkness.
Our fascination with the stars is an ancient one, stretching back to times when people could only look up in sheer awe. It was the invention of the telescope, however, that truly started to peel back the layers of cosmic secrecy. What might appear as a simple tube is, in reality, a gateway to the infinite, serving not merely as an instrument, but as a conduit between everything we know and all that remains unknown. Imagine how different our world would be if we still held the belief that Earth was the center of all things. Technology has shown us that we are but a tiny speck in a boundless stellar ocean. A truly monumental leap in space technology was the creation of robotic probes and satellites. These compact explorers have journeyed across our solar system and ventured into the void beyond, transmitting data that has utterly redefined our comprehension of planets, moons, and asteroids. Can you put yourself in the shoes of a scientist seeing the first clear images from a distant world? The profound sense of wonder at witnessing the Martian landscape or Saturn's rings in high definition is an experience beyond words, marking a new epoch in exploration, where imagined realms become visible realities. The digital era ushered in an even more powerful class of instruments, space-based telescopes. We are, of course, referring to observatories like the Hubble Space Telescope, which has provided breathtaking images that have completely altered our cosmic perspective. What incredible discoveries have these windows to the universe revealed? From confirming the existence of exoplanets orbiting other stars to witnessing the birth of ancient galaxies, Hubble has served as a silent, steadfast observer of cosmic history. Yet, space exploration extends far beyond the realm of visual observation. Modern technology has given us instruments capable of detecting radio waves, X-rays, and other invisible forms of radiation. Did you realize that a vast portion of our cosmic knowledge is derived from wavelengths that our eyes cannot perceive? These invisible observatories have unveiled spectacular phenomena like black holes and the explosive deaths of stars in supernovas, dramatically enriching our understanding of the fundamental processes at play in the interstellar medium. In recent times, artificial intelligence has also assumed a vital role in our exploration of space. Sophisticated algorithms can sift through immense volumes of data with incredible speed, identifying subtle patterns and anomalies that might otherwise elude human researchers. Just picture a machine being the first to identify a new exoplanet. This synergy between human intellect and machine processing is elevating cosmic discovery to entirely new heights. Computer simulations represent another indispensable tool in the modern astronomer's kit. By employing complex mathematical models and advanced visualizations, scientists can digitally reconstruct cosmic events and rigorously test theories about the universe's origins. Have you ever wondered what a collision between two galaxies would look like up close? These simulations offer more than just a preview. They provide critical insights that help us make sense of the real phenomena we observe across the night sky. Even 3D printing is finding its place in scientific education and public outreach, making the cosmos more tangible. Can you imagine the experience of holding a detailed physical replica of a distant planet or a swirling nebula in your own hands? Such models forge a much deeper, more personal connection to concepts that are often abstract and remote, effectively bringing a piece of the universe down to Earth and making science more accessible to everyone.
Of course, our advancing technology also presents us with challenging ethical questions. As our reach extends further into the cosmos, we are forced to contemplate the potential consequences of our explorations. How, for instance, should we responsibly manage the discovery of extraterrestrial life? Technology, it seems, provides us with new answers while simultaneously generating profound new mysteries that we must face together as a species. The future of space exploration is brimming with excitement, fueled by next-generation projects like the James Webb Space Telescope, which is engineered to peer even deeper into cosmic history than Hubble ever could. This new observatory holds the promise of transforming our understanding of how stars and planets come into being. What unimaginable wonders is it destined to show us? Each technological leap makes the prospect of a paradigm-shifting discovery more thrilling than ever. Technology has also been a powerful catalyst for international cooperation in space. By pooling resources and expertise with other nations, we are witnessing a truly collective human effort to unravel the universe's greatest secrets. What can we accomplish when we work in unison? This kind of collaborative research not only strengthens bonds between nations, but also serves as a poignant reminder that we all share a single, precious home in this vast and wondrous cosmos.
Every technological step forward is a move toward a future filled with incredible possibilities. As we persist in creating new tools and refining our methods, the dream of interstellar exploration inches closer to reality. What will be the next great breakthrough that forever alters our view of the universe? Human curiosity is an unstoppable force, and technology is the vessel that will carry us toward these new and unknown frontiers, bringing us ever closer to understanding our place in the grand cosmic tapestry.
Venturing into space is more than a physical trip. It's an intellectual odyssey that compels you to contemplate your position in the universe and imagine the possibilities that await. Consider how technology has transformed our very perception, starting with telescopes. These instruments are no longer simple tubes with lenses. We now deploy space-based observatories capable of capturing breathtaking images of faraway galaxies and exoplanets. They detect light across various spectra invisible to our eyes, granting us a new way of seeing the cosmos, as if we have been given vision in the dark. Artificial intelligence is another transformative force in this field, acting as an indispensable partner in discovery. Picture an assistant that doesn't just process data, but actually learns and enhances its capabilities with every new mission it supports. We utilize this technology to sift through the colossal volumes of information gathered from our cosmic voyages. In fact, it's because of artificial intelligence that we've identified exoplanets that might have otherwise remained completely hidden from us, demonstrating how modern tools are unlocking new frontiers of understanding. And what of space travel itself?
An endeavor once limited to a select group of highly trained astronauts is now poised to become a new arena for human exploration. Private enterprises are pioneering reusable rocket technologies that promise to drastically lower the cost and increase the accessibility of spaceflight. You can now envision a time where booking a journey to the moon, or perhaps even Mars, is as straightforward as planning a vacation, a development that could fundamentally reshape our connection to the cosmos.
Let's now turn our attention to the robotic explorers that serve as our envoys to other worlds. These are not merely metallic contraptions rolling on the Martian surface. They are sophisticated discovery machines built to operate where humans cannot. Capable of enduring the extreme cold of planetary poles or the planet-wide dust storms on Mars, these robots transmit crucial data back to us. This information is vital for understanding other planets and laying the groundwork for establishing a human presence there one day. Furthermore, the future of space exploration is increasingly defined by international cooperation, a pivotal shift from past rivalries. Nations across the globe are now pooling their resources and expertise to achieve common goals. Imagine a mission to a distant star system powered by the combined efforts of scientists from every continent. Such diversity in thought and methodology can spark innovative solutions that might never emerge from isolated efforts, turning this great endeavor into a truly global adventure.
Alongside this spirit of collaboration, the principle of sustainable development has become a central focus. As our activities in space intensify, we face important questions about how to explore responsibly while safeguarding the environments we encounter. This includes protecting our own planet, as well as the celestial bodies we visit. New technologies are being developed to ensure that future missions can be carried out without leaving a harmful residue in space, allowing us to explore other worlds without contaminating them.
We also cannot overlook the profound search for life beyond Earth. As our telescopes and probes become more advanced, we move closer to answering one of the most ancient questions humanity has ever asked. Are we alone? Active missions targeting the moons of Jupiter and Saturn, which are thought to harbor vast liquid water oceans, exemplify how we're broadening our search for biology beyond our solar system. The coming decade may very well deliver astonishing discoveries that will forever alter our view of the universe. Of course, the exploration of Mars remains a primary objective in our cosmic ambitions. With sophisticated rovers continuously beaming back data, the prospect of humans walking on Martian soil feels more tangible than ever before. In parallel, extensive research is underway to determine how we might live and work on Mars, paving the path toward eventual colonization. Our success in adapting to such a harsh environment could ultimately decide our fate as an interplanetary species.
This rapid expansion of knowledge is also being fueled by a renewed focus on education and public outreach. As more people like you develop an interest in space, new avenues for research and innovation open up. Educational initiatives are inspiring a fresh generation of scientists, engineers, and visionaries who will almost certainly shape the course of future interstellar travel. Ultimately, it is our innate human curiosity that has always served as the catalyst for discovery.
So, what should you anticipate in the years ahead?
Space exploration is currently at a pivotal moment. Through a blend of sophisticated technology, global partnership, and a resurgence in educational interest, we stand on the threshold of a revolutionary new era. The notion that humans could one day inhabit and work on other planets has shifted from science fiction to a concrete possibility that may soon define our reality. The only question is, are you prepared to join this incredible adventure?
Have you ever gazed at the night sky and considered what exists beyond what your eyes can perceive?
The immense ocean of interstellar space that separates the stars is not a void, but a domain brimming with mysteries and potential. It's a fitting moment to reflect on our journey through the universe and appreciate the significance of this vast expanse. Our Milky Way is just one of innumerable galaxies, with each star an island in a cosmic sea, a sea filled not with emptiness, but with the very matter, energy, and phenomena that continue to challenge our comprehension.
During our journey through this cosmic ocean, you've come to see how every component, from interstellar dust to dark matter, performs an essential part in the universe's grand ballet. In the context of this cosmic performance, you might be interested to know that stars move in a coordinated harmony, directed by the inescapable pull of gravity. While each star charts its individual course, they are all bound together by an invisible gravitational web, a connection that not only creates the stunning vistas you observe in the night sky, but is also critical for the birth of new stars, and, by extension, new solar systems upon which life as you know it relies. We've learned that the cosmos is brimming with unexpected wonders, from nebulae that resemble celestial masterpieces to black holes that fundamentally challenge your grasp of physics. But what of the potential havens for life? The ongoing search for exoplanets has started to reveal that we may not be alone in this immense expanse. Each new world we identify edges us closer to resolving the age-old question that has captivated humanity for millennia. Is there anyone else out there besides us? In recent years, space exploration has undergone a dramatic transformation, driven by technological breakthroughs that let you peer deeper among the stars than ever before. Our probes, telescopes, and satellites serve as your remote eyes in the cosmos, with each one peeling back another layer of the universe's mystery. What other enigmas does the cosmos conceal? The answers will only be revealed through the passage of time and the persistence of human curiosity. Another captivating subject is the very expansion of the universe. Can you picture space itself stretching outward, much like an inflating balloon? This cosmic phenomenon provides insights not just into the universe's origins, but also into its ultimate destiny. As galaxies continue to drift apart, your comprehension of the cosmos deepens, becoming ever more intricate and exhilarating. Cosmic spectacles like supernovae and pulsars are essentially the universe's own pyrotechnic displays. Every brilliant explosion and rhythmic pulse narrates a story about the life cycle of stars and the ongoing evolution of the cosmos. Ultimately, each star you gaze upon in the night sky is a reminder that the universe is in a perpetual state of flux, and you are an integral part of this magnificent story. The profound significance of gravity simply cannot be overstated, as it is the fundamental force that holds the universe together, enabling the formation of galaxies and solar systems. Without its influence, the cosmos would be a chaotic and utterly inhospitable void. Gravity's reach extends beyond celestial bodies, shaping your own existence by anchoring you to Earth and everything familiar. When you reflect on all we've learned, it's natural to feel a sense of awe at the sheer scale of the universe. Yet, every fresh discovery and each unanswered puzzle serves as a powerful motivation to continue our exploration. Human curiosity is a relentless engine, the very force that has compelled us to construct spacecraft and telescopes, and to dream of one day voyaging between the stars. The future of space exploration appears incredibly promising. With every new technological leap, previously locked doors to the unknown swing open. It's conceivable that in just a few years, we might embark on interstellar voyages that currently seem confined to science fiction. Just think about what you could discover out there. New forms of life, entirely different worlds,
and perhaps even the answers to questions we have been asking for centuries. In this voyage across interstellar distances, you have explored not just the stars, but also the very essence of our own humanity. The shared pursuit of knowledge binds us together, inspiring us to look skyward and contemplate what lies beyond our current reach. Each twinkling star serves as a potent reminder that while you may be small in this vast cosmos, your questions are immense, and your aspirations are greater still. As we conclude this exploration of interstellar space, it's vital to remember that the universe is a theater of constant change, where every answer we uncover only gives rise to new questions. This ensures that the cycle of curiosity and discovery is perpetual. So, the next time you find yourself looking up at the night sky, consider all the stories yet to be told and the marvels that await us in the future. The grand adventure is truly just beginning.